G'day everyone, it's John Brandis here with IT 535 Capture the Flag. This is the first assignment of, I hope, not many. What we're doing today is we are going through a vulnerable machine as part of the syllabus from Tiago Tavares, where we're looking at a bit of a Drupal host that's running on Ubuntu, and we've got to get 6 flags, 2 by way of filename flag.txt and a handful of users to enumerate both their username and password. We have a 15-minute time limit. For those watching this, where we get a lot of fast forwarding, you're watching the 15-minute time limit version. For those who watch the longer one, well, we're in for a bit of a treat. We'll do some bit of NDR. First thing that we're going to do is we're going to do a bit of a recon mission. Now, as Nmap takes a little bit of time, I've kicked it off in another window over here, but we are running an Nmap scan on the 192.168.102 network here in my home, sudo John Industries. We're looking for all ports. We're looking to expose vulnerable services, and that is kicking off now. I've got an excludes file in this, as I said, so I've excluded all the known hosts that I have here, just because, for brevity. So what have we got? This has come back now. We have, on this network, glasses don't work from afar. Oh God. We've got open port. What host is this, first of all? 202. 192.168.102.202. Cool, DHCP has given that. And it is this host. It's running Ubuntu, 2.7 kernel, a bit old. It's got 22 open, SSH, fairly common. 80, so it's running a web server. Some type of banner, that'd be interesting to pull. Running 1898. Apache, so it's running a web server on a non-standard port, and the application underpinned is Drupal 7. And furthermore, a robots text has pulled these. We could have used something like a fuzz or a nicto to get some more in-depth information, but I'm interested mostly in changelog.txt, so its IP was .202. So let's have a look at 192.168.102.202, and that was listing on port 1898, and forgive that if you're seeing some things that I've already done, should have cleared cache. Changelog. Now this is something that's given away some great information already. If you can see where the mousey is right here, it's advertising that this is running an older software version of Drupal. So I made a note of that. Drupal 7.5.4. Really good information as we now head over to the world of Metasploit. And we have a bit of a look of what do we know by way of vulnerabilities. We can, I like search exploit, because I'm inside Metasploit itself, for Drupal. What do we get? Again, we said we were looking at 7.5.4. I find this much more robust exploit search than within within Metasploit itself. So I'm here. Drupal gettins. Drupal gettin 2. This could be the goods. And we'll just make sure within exploit itself, search for Drupal. And the reason I say that, it's actually going to tell us, if you can spell, it's going to tell us the actual name of the exploit we're going to have to use. And we're looking at Drupal gettin 2. So when we go to use, we will actually be that. It's a copy. So we're in Metasploit, use, and it says the exploit. Let's fire that one up from the database. Now we've got some options to configure here. Now I'm going to make this screen a little bit bigger. I apologise if it's a bit small. No one needs to care about that down the bottom. I just like to have my desktop sorted by, this was in Metasploit, this is Kali up here, the shell, even though they're the same box, and this is my target. I didn't want to put the target branding up there in case, I got sued. So we're in here, let's look at the options we can set. Show options. The host and the port, well we know the host. The host is that 202 character. So we can set our host as 192.168.102.202. And the port, it wasn't standard. From memory, and being memory, from the output, it's 1898. So set the port that we want to go against as 1898. We can actually accept some of the defaults on what we're listening on for the reverse shell. Local, this host, so 233, that's the IP of the Kali box up there as indicated by, and quad 4. Let's exploit. And that's a big one to note, because if you've got NDR, you can actually see this one happen. Exploit. Target is vulnerable. As I take a bit of sippy time from the smelly cheesecake. Sponsorship opportunities are available if you are interested people at Smelly Cheesecake. I'm just kidding. They dumped a lot of chocolate in this one. Not a lot of coffee. Excellent. So I'm taking one more sip. We have actually got onto the remote box. Booyaka. Let's take a look at some of the things. I actually just want to know, where are we first of all? Where did we get to? I just want to make sure that I'm not on the local box, my own box. IP adder. Shell would help. IP adder. What we say it was? 202. Yep, okay, we're on that box. var HTML. Now, we haven't tripped any alarms as yet, I don't think. what we should do though is, whilst we got time, and I have made, in the interest of time, I've put together a list of things at this point. I want to be getting some facts, so I want to know what OS this is. I know it's Nix, it says it's Ubuntu. Let's actually, I'm just going to put some fun facts to Notepad, or paste bin, if you will. So that's going to be coming up useful very, very soon. I want to do a netstat Toulon, if you're French. Why am I doing this? I'm interested. See, for example, this didn't come up in our Nmap Scan. Why? It's only listening on itself if you can think loopback, whereas the others here are listening on all interfaces, and all interfaces IPv6, IPv4. So that's a good one to note, that this box is also running SQL Server. It's MySQL, just because I know things. I drink and I know things. We want to see, what are the other users on the box? Who are the users on the box? We've got Tiago Silva, live at Gladstoneberry. The rest of them, root is not no login. Gonna have me some fun. So we'll be able to get that. The rest are all no login. So we've got two users that have OS accounts, Tiago and root. Interesting. Now, because I may have done this once or twice, and we've ascertained that this very much is just a Drupal install, and we can confirm that by just firing up a new browser, going to the box, http 192.168, what was it? 102.202 on 1898, and it is Drupal, and we have a fellow called Tiago, and he's also got, now with Drupal, just because you have an OS account, an application account doesn't mean you have an OS account. And we got another fellow called Edda. Okay. So let's have a look, because it is Drupal and SQL is on that box. We will probably be able to find the settings for the connection between the front end to the back end, again, same box, over MySQL. Oh, we've got a settings file, config file, we didn't get back an error. It's at the top, I should have headed it. Oh, what do you know? I'm going to copy and paste this to my trusty clipboard, or trusty paste bin, if you're into self-hosted. That will come in handy for later. Okay, I think we're now at the point where we can actually pull down an exploit suggester kit. Now, if this is very poor perimeter security by the admin, and yes, I am the admin on my trusty Juniper firewall. Oh, there's no proxy configured, no whitelist, no blacklist. This will work. Otherwise, you would have had to have messed around and built yourself a web server. We've been able to go out and pull down a payload from the internet, and if we have a look, ls-l, what was it called? Linux exploit suggester. Now, let's have a look at some of the other files. There's some weird ones. I didn't look at that. Let's first of all make this executable plus x, because x can give it to you. And the name of this file is the Linux exploiter shell. Copy, paste, and we'll ls just -l that. Now at this point in time, we may have, on this network we haven't tripped any alarms, but we have now given, we can execute that. But what else we got? We've got, in this directory, we have an MP3 file, includes files, that's interesting. We do have, now, just because I have read the docs, the actual hash of this file is quite significant, but it's outside the scope of this. Let's actually see, what do we have by way of music and entertainment from this particular file. Not sure if anyone can hear that. Bit of Mexican music. Sounds like an old El Paso ad. We also have another audio file, audio M4A. Let's copy that bad boy. What do we get? It's screaming out because you probably can't pick it up in this microphone. User Tiago. Tiago. This is not very real word, by the way, but just know that that is what's come up. So we've been able to get some intel. Let's run this exploiter. Now we've given it execute permission. And again, because I probably could have given a path to the actual bash shell, and I could have got tab complete. Excellent. So that file, that, as I take another sip from the good people at the Smelly Cheesecake, we've been able to download and execute that payload, and what it's done, it's gone and looked at what vulnerabilities are potentially available to execute on box. Now I'll go up to the start. And again, remember how I said this will be useful information later? What version of code we're running? This is Ubuntu 14.04 Trusty. Now this is an LTS. I would say you don't see it, but I did see it for a client this week. It's who actually hosts the Ubuntu mirrors, and there's still a lot going for Trusty. So we've got some Chocolate Robot, Dirty Cow 2. We get a bit of a link to the actual URL where it hosts this. Now, here's something I've done earlier. Let's just copy that in here. Now, I'm still in the web working directory. Should I be somewhere else? A lot of people will put a tripwire on this, so if this directory changes, people will be alerted. Places like temp, not so much. Let's pull down this. And as expected, because I am the firewall admin here in my house, that saved. So now I actually need to rename it. CP 40, what is that? 847. I'm at that distance where my glasses don't work. I need the TV watching glasses, and I have no idea where they are. 40847.cpp. ls-l, just want to make sure that I do have it as CPP. I thought it was a bit bigger than that in size. Anyway, we've got now that code. We've got to compile it with the Gcc Compiler. To do that, again, here is something I've done earlier. I can take that now, and I can compile, and then that will produce an application that I can actually run. Now that is running in the background. I'll give it a minute, and then I should be able to just simply run this. Let's have a look to see if it's finished compiling. ls-l, voila, Dirty Cow 2, it is in there. Is it executable? Yeah, it is. Cool, we should be able to run Dirty Cow 2. Again, my glasses. Cool, what has that done? Now I'm going to put this first of all in the clipboard. Copy. Oh, it's not the clipboard, it's my ever trusty paste bin. Now what has that done? If we cat out etc password, we can see what it's done. Before, when we had a look around at what users were on box, root didn't have a hashed password here. It was in the shadow file where it should be. Password file shouldn't contain password file. It did back in, well, when I was first touching Linux, when it was Mandrake. So yes, I'm old. But these days, it doesn't live there. So that will not survive a reboot. And we know what that equals because it just equals Dirty Cow Fun. So now we're at the point where we are at that box. And if I go down to my trusty machine down here, and I run clear again because there's too much gobbledygook on the text, we can fire up an SSH session. And this is why if you're running SSH, make sure that root can't log in. We can go SSH root at 192.168.102.202. That was the IP. Yeah, I do accept the fingerprint. And it was, I've got no chance of remembering this, Dirty Cow Fun. And second two are caps. Dirty Cow Fun. Booyaka. We are in as root. Man, that's some evil right there. So what we're going to do now that we're into this box, we got some flags to capture. But first of all, we've probably tripped a few flags of our own by doing this. So what I want to do is quickly, I want to do some more recon, if you will. While I'm on box, I want to enumerate the root and Tiago users because we've identified those as two users on box. Now, you might say, John, it's already Dirty Cow. No, that's what we set. We're going to look at the shadow. So we're going to grab root in etc shadow, if I could spell, and cramp in the hand. I want to put that out as 2crack.txt, obviously. Not the greatest fail name. And we wanted the other guy as Tiago. Does he spell it with H? No, he spells it with an I. Tiago. So now if we cat 2crack.txt, and we can tab complete because we're in the shell, we've got these two. Now, I'm taking this across here, and copy. Now, it's on the target machine. I'm going up here, where I'm going to have me some fun. Need to make that smaller. I don't need this window for now. I just need this big one here. Now, I've got a directory, and in this directory, okay, Rocky word list. That is a word list that's on the sec list. I think the guy's name is Daniel Meisler, but it's community contributed. It has a plethora of passwords in there, and it's ever growing. There's tools like Cure, which we'll get to at the end, where you can generate your own password list, but this is rather large, and when I tried this, it took 17 hours. So what you're about to see will be a cache, an echo of that particular run. So we're going to now create a file. Because I like Vi, we will call it shadow hashes.txt. And in here, I'm just going to dump in those two lines that we had for root and Tiago. Now, some people won't put the root and Tiago in there, they'll only put the hash. However, John the Ripper is smart enough to know what's the hash and what's just, well, supporting arguments around it. Okay. My System 76 keyboards doesn't like me today. So now we can actually use John the Ripper across this. So, funnily enough, it's got John -- word list, and word list equals rockyou.wordlist, and my input file is shadowhashes.txt. Funnily enough, you may see that I have already done this before. And fork 500 is to really just establish more, well, threads, if you will. It's not really threads, though. Otherwise, this would take forever, which it did the first time I did it on the processing power of a Raspberry Pi. What's happened is, it's identified the types of hash, it's been able to go over that file, compare the hash of that random password generating word list from RockU compared to what we have as known hashes in etc shadow, and to view the passwords from John, we actually just go John -- show, and you've got to specify the shadows.txt. So what we've been able to enumerate is two users, root, happy birthday, Tiago, backups rule. And remember how I said I keep the usernames in there? That's why, because if you're doing this against a larger file, you're going to have no idea where it all was. As I take another sippy, you can hear my voice. Okay, we've got those two. Whilst we're here, and I'm down the bottom box, we can, by the power of SQL maps, I am root. Get it? I am root. What we can do with the SQL table is, the way Drupal works is it will actually put, it doesn't use something like AD or something, or another identity management system, IDP. It's putting the username and passwords in a specific table inside the Drupal database. Now, we already know from the recon work we've done, we've got the Drupal user, we've got the Drupal password to connect to the back end, and we have the name of the database. So we've got a fair bit to enumerate on. All you need to know is, what does the schema look like? And we know that. We know there's name and pass. So we've got a fair bit to work on. We can get some good information out of this. So again, the trusty paste bin. So we can run this here. Paste. This is the box that we're on, the one that we owned as root. The password was, what was the password? It is Virgul. God, how am I going to remember that? VIRGULINO. Cool, we've been able to dump. These are actually, in fact, the same. So Tiago and Edda have the same password. That's kind of interesting. So you know what we're going to do? We are going to make another file. So I'm going to call it SQL hashes. So vi SQL hashes.txt. And I'm going to insert what I just copied, paste. And I'm going to save that off. Now I need to use John the Ripper again. I'm just going to use, actually make sure I've got it in this right directory, ls-l. Yep, it's in there, and so is my word list. So I'm going to use John -- word list, and we're going to use RockU. Now this is not shadows.txt, this is SQL hashes.txt. SQL hashes.txt. Okay, John will work over that. Now, in the interest of time, again, how I said I've cached this because this took a long time to work last time. So we can use John -- show SQL hashes.txt. Now, the password that we've just cracked there is under the bridge. And notice how it doesn't have a username at the front, because we didn't have that type of information. So now we've got the username as under the bridge. If you're thinking back to the different passwords we've got, we should actually put them in our notepad. We've got, put it down here. And now we've got this new one as under the bridge. Copy that. We're just going to put it down there. And we'll just call this John passwords. Awesome. That's some flags in itself right there. So while we're here, we've actually got some other flags to capture. And because we're on the box, we can cheat a little bit. We can find, as I get a bit of an eyelash on my face, slash, and it's type a file, and the name of that file is flag.txt. And how do we know that? Because the teacher actually told us in our objectives, two of the files are indeed flag.txt. Hopefully my microphone's coming through nice and good now. We do have two. I don't know why that didn't work before, but what are they? Cat slash root slash flag.txt. Watch the world spinning. Cool. That is a good one right there. I have no idea what that means. And the next one is we want to cat out home Tiago, and it's flag.txt yet again. Pass the duchy to the left hand side. Excellent. So right there, sadly this is 29 minutes, so I've probably failed. We've been able to capture the objectives via the passwords and the two flag.txt files. So we've got root, we've got Tiago as a user. We've actually got his application as well. Actually, hang on. Let's go over. I want to see. Can we log in as Tiago? And what did we say it was? So his username was Tiago. And what did we say in pastebin that his application password was? Under the bridge. Under the bridge. Oh, I don't want to save it. Oh, cool. So how as that can we update something for Tiago? Update. I don't know who Alex is. Subject. Backup. Routine. 1 plus 1 equals none. Because I can't think of anything else. Let's save that. Cool. We're in. Backup routing. I didn't know I wrote routing. Anyway, I must have. So, comment has been posted. Home. 1 comment. 1 plus 1 equals none, because that's very true of backups. Okay, now if you're watching, that will stop here, but I just want to have a look at some of the things that we've been able to see via NDR. I want to have a look at how many... So this was acting as a HTTP server. Let's have a look over the past 15 minutes. I was able to identify some very strange behavior. So TCP 444. Now the reason, actually while we're here, let's run a brute force attack using Hydra. Where would Hydra be? Now the actual syntax for Hydra, let me find that. 1 second, Hydra-L, what? 1 second. We could actually say Hydra-L, not 203, 202. And the word list, we could just, well, we could say rock you word list. Rock you word list, dash threads for... Now, the problem when we use something like Hydra, which is brute force, it's going to fire up a lot of network detections. We're going to see it here on the network. So this is Evolved Net Server. It actually does go across the wire, so we will see some SSH traffic records. We're going to see it. Let's refresh it, but we might bring it down to the last 5 minutes. Let's bring it down to the last... okay, 5. Now again, this is going to be one of them times where I speed up the recording. So anyway, when this actually does start to kick off Hydra, we're going to see it that the network detection equipment has actually caught it. It's got a very distinct back-off timer, and I've actually caught this in the wild. There's some things that you see in common, which is the size of the actual packet when it's trying to guess the username and password. For the most part, varies very slightly, and the back-off period that I was telling you about just there. They're things to keep an eye out for. Kill, is a great password generating tool. What it does is you specify kill, you give it the target URI, sorry. And then it looks at the page and it tries to pick apart some things so it could generate a word list specific to that. And then you can use it in conjunction with Hydra, so you don't need to use Rocky, because Rocky is huge. This thing will run all night and into tomorrow if we give it the opportunity. But for this lab, it was a little bit too perfect. It actually worked out the password for young Tiago straight away. I wouldn't say Tiago, it just generates a password file. And as we identified, we had from just the Drupal page, Eda and Tiago. So obviously, we'd chuck a root in, but it worked a little bit too perfect. Now, another one that I wanted to point out is when we were doing the reverse shell, back to Quad 4 that we spoke about, our network detection platform, it had all the forensic analysis for the packets. So we could actually see what this exploit was. So we could say, okay, for example, if we see writing UDP socket, UDP for Peter, socket, and that's a really bad one actually because that would be very common, in the payload, and the port was TCP 444, do something. And that would be way of a trigger to negate default applications, like a default Kali stand-up, using Metasploit, as some type of remote web shell. If we see that type of behavior on the network, that's where NDR can definitely pick it up, and that's maybe one I should try after this. But this is, yeah, just going to packets and downloading the packet for that particular point in time between those two hosts. 233 was the Kali box, and 203, well, this is the lab, but when I tried this before and I wrote up the documentation, 203 was the actual vulnerable target, but in prod, 202. So that's useful information as well. Now, if we go back to the screen, we should start to see some SSH activity on the wire, and there we go. There's the back off. But I was more interested in, apart from the L2 bytes. Notice they're only going up slightly, well, they're not even going up. But that's some very interesting information. We see it. It's very predictable, isn't it, that pattern there? The back off, again. So a handful of sessions, back off. A handful of sessions, back off. So other platforms would not detect this, but we have. So we could write some type of network detection rule that if we see, what's that? How many SSH sessions? We've got in a 1 minute window, we've got 2, 4, so 6, 10. So if we see more than 8 SSH sessions in a 1 minute period, we could say that's breaking our line in the sand. I wouldn't go with a trend, I would go with a threshold in this scenario. Anyway, All the resources and sources that I've used, the sec list that I talk about from Daniel Mosler, the Drupal schema, and the actual people who wrote this walkthrough, the links are there. I thank you very much for your time. It's now 37 minutes. I have to tune this down to 15 minutes somehow. I'll see you all on the flip side. Thank you very much.